Hey, I hope you're here to learn how to factor trinomials because that's what we're doing. Okay, I'm going to be pretty detailed in this video. If you were just looking for something really quick, I've got a video linked over there. Also, I've got a few other videos linked because this is not the only way to factor. This is probably the one you'll use the most, so it's a very important, but it's not the only way. So if this way isn't working for your particular problem, or if you're being asked to do it another way by your teacher, I've also got some videos linked over there of some different ways. Last thing I've got linked is if you've got a number out front here in front of this x squared that can't be pulled out, which we'll talk about what that means in just a second. If you got a number there, it's a little bit different. So I've got a video linked for that also. Okay, let's get started. There are just a couple things before you try and factor these that you want to check very quickly. So the first thing is you want to make sure everything is on the same side of the equal sign. Now you might be saying, there is no equal sign. Well, this is equal to 0. Just a lot of times when we're just factoring, we don't necessarily write the 0. So if it's looks something like this, before you try and factor or solve it, you want everything on the same side. Okay, so that's what that should look like. The other thing is, I mentioned half a second ago, is you always want to make sure you check and see if there is something that can be factored out. Factor out the greatest common factor. What does that mean? All that means is if you notice that there's something in common about all of them, it could be a number, it could be a variable. I notice here all these are even, so we can pull a 2 out. So this is what it might look like. Okay, when I pull a 2 out, that's left with an x squared, that's left with an 8x, that's left with a 7. If I were to distribute that back in, I would get this. Why do I pull that out? This is much easier to factor than this. Okay, so we always want to check that. That doesn't apply to any of these problems we're doing in this video today, but it's really important to get in the habit of checking that. Okay, you're like, enough talking, let's do this problem so I can get my homework done, right? Okay, first of all, what are we doing? You've probably been doing this where you multiply 2 parentheses, you get something like this, you combine like terms and get something like that, right? Well, now we are just doing the opposite. We are going from here to here. Okay, we want to find out what 2 parentheses multiply together to give me that. We're looking for the 2 parentheses. Okay, so let's start. Here we go. I want to know what 2 parentheses will multiply together to give me this. Okay, how do I do that? Okay, so you don't have to just guess random numbers. Someone figured out this really cool trick. It's not really a trick. It's anyway. Okay, here we go. So you take whatever number is being added on the back, as long as make sure it's all in order and everything. Whatever number is being added or subtracted on the back here, you multiply that by whatever number is in front of your x squared. Now, you might say there is no number in front of my x squared. Well, there is a 1 here. We just usually don't write it, but there is a 1 there. So we do 12 times 1, which just gives me 12. So you might be saying, why do we have to multiply it by 1? Well, in other problems, like I talked about earlier, where you may have a number there, it does matter. You need to multiply it by that, okay? So in this case, it was just 1, so it's just 12. So we need to find 2 numbers. This is where it's kind of fun. It's kind of like a puzzle, and you're like, okay, weird internet math lady. But we need to find 2 numbers that multiply to 12 and add to 7. Okay, where did I pull that 7 from? Oh, from right here. Okay, 2 numbers, multiply to 12, add to 7. Okay, so how do I go about doing that? Well, I'm just going to list the factors of 12. So that's the numbers that multiply to give me 12. So 1 times 12 gives me 12. 2 times 6 gives me 12. And 3 times 4 gives me 12. Okay, so 2 numbers, they multiply together to give me 12, add to give me 7. So you might notice, okay, 12 plus 1 is 13. No. 6 plus 2 is 8. No. 3 plus 4 is 7. Oh my gosh. So 3 times 4 equals 12. Ding, ding. That's what we needed. 3 plus 4 equals 7. Oh my gosh. That's what we needed. So now that we found our 2 numbers, guess what? This is all you have to do. X plus 3, x plus 4. And those are the two parentheses that multiply to give you that. You can always check, make sure you're right, by just multiplying those back and make sure you get that. Okay? Now, if you are asked to solve, there's one more step. Okay? If you were just asked to factor, you're done. Congratulations. Congratulations. If you were asked to solve or solve by factoring, really simple to get from here to solve, okay? Remember how we said to get everything on the same side because this is really equal to 0, okay? If you're asked to solve, it'll probably have the equal to 0 there for you. So if you're asked to solve, all you need to do now, since this was equal to 0, is you set each of these equal to 0. So x plus 3 equals 0, x plus 4 equals 0. Now, you've probably done this a million times, just get x alone. So if it's x plus 3, I subtract 3 from both sides. Remember, as long as I do it to both sides, it stays even, true. So I get x equals negative 3. I need to subtract 4 from both sides here to get x alone. So I get x equals negative 4. Okay, if you are asked to solve, that's your answer. If you were to plug negative 3 in for all these x's, you would get 0. It would work. If you were to plug in negative 4, it would also work. Okay, so those are the two answers that x can be. Okay? Okay, next problem. This one has a negative, but it's not too bad. We're just going to do the same thing. Okay, so I take this number, negative 21, multiply it by the number in front of here, which again is a 1 this time. So negative 21 times 1 gives me negative 21. I'm looking for a number that multiplies to negative 21, adds to positive 4. Okay, you might just want to like put a little note on the side or something. That's what we're looking for. Okay, so I know a positive times a negative gives me a negative. So when I list these factors, one of them is going to be positive, one of them is going to be negative. Okay, there's a couple different ways you could go about it. So we're just going to list the factors here. So 1 times 21 and 3 times 7 give me 21, but I need a negative 21. So that gives me a couple more possibilities. I could have negative 1 times 21, or I could have 1 times negative 21. Does that make sense? Those are both going to give me negative 21. I can have negative 3 times 7 will give me negative 21, or 3 times negative 7. Okay, you're just switching where the negative is. Why does that matter? Because I want them to add to positive 4. So which of these combinations will add to positive 4? Well, negative 3 plus 7 gives me 4. So negative 3 times 7 gives me negative 21. Negative 3 plus 7 gives me 4. Okay, those are my two numbers. Now, I'm just going to put them with the parentheses. Okay, those are my two parentheses. Again, you can always multiply them out to make sure you get this. Okay, if you are asked just to factor, you're done. If you are asked to solve, remember this will be equal to 0. If you are asked to solve, you just set them equal to 0. Okay, set each of them equal to 0. So we've got x minus 3. Add the 3 to both sides. We get x equals 3. Subtract 7 this time because it's being added and we want it to go away from that side. So we get x equals negative 7. Sweet. All right, last one. This one, the middle number is the negative 1. Okay, so here we go with this one. Same thing we've been doing. 20 times 1, because there's a 1 here, gives me 20. So I am looking for a number that multiplies to 20, adds to negative 9. Okay, Now, I'm just going to list the factors of 20. So I've got 1 times 20. What else? 2 times 10. 3 doesn't go in. 4 times 5. And that is all of them. So all of these multiply to 20. But I need to add to a -9. And none of these are going to add to a -9. But guess what I remember? A negative times a negative also gives me a positive. So we could also have -1 times -20. That also gives me 20. -2 times -10 also gives me a positive 20. -4 times -5 also gives me a positive 20. So now when I look at those, well, -4 plus -5 gives me a -9. So I've got -4 times -5 gives me 20. -4 plus a -5 gives me -9. So -4 and -5 are my two numbers. So we've got x minus 4 times x minus 5. And you are done. If you're just asked to factor, if you're asked to solve, we just set them equal to 0. X minus 4 equals 0. X minus 5 equals 0. I'm going to add 4 to both sides on this one. I get x equals 4. Going to add 5 to both sides on this one. So I get x equals 5. Look at that. Oh my gosh. Hopefully this is making sense. One last thing I did want to mention is, what if you get a problem like this? Well, there's a couple different things you could do. But for this way that we've been learning, you might go, there's no x. Well, guess what? There are 0 x's. So with this one, it would be -4 times 1. So you get the -4 that you're trying to multiply to, and you're trying to add to 0. So it would be 2 and -2. Okay. All right. That's just a note if you happen to run into one like that you need to factor this way. Okay. Hopefully that made sense. Hopefully you're feeling really good. This isn't too bad, hopefully. Hopefully you can get your homework done, go to bed, have dreams of math that are nightmares.